Good day, everyone. Now, we will be talking about the mixture and their characteristics. So, what is mixture? Mixture are composed of two or more substances mixed together. They have different characteristics. And what do you think are they? Mixture may be solid, liquid, and gassed. They can be solid like a marble bottles, they can be liquid like a water or juice, or they can also be a gas like the balloons. Another characteristics, they can be homogeneous and heterogeneous. Homogeneous like those of the mixture of water and brown sugar, and heterogeneous like salad. And now, we will present the demonstration of the different types of mixture. First, the material are jar, water, sugar, oil, food coloring, sand, and equipment for separation. And this time, we first demonstrate how food coloring dispersed and spread through water and to observe the behavior of liquids when they mixed rather. As you can see in the two images, the first one is having clear water, and the second images, the food coloring drop hits the water, spread quickly through the liquid, and you may see a streak form before it fully dispersed. This happens because food coloring is soluble in water and will gradually mix in. For you to know the step, we have provided a demonstration of how we mix food coloring with water on the next slide.
The food coloring starts to spread out gradually from the drop. You might see thin streaks of color radiating outwards. The water molecules are moving moderately fast, so they push against the food coloring, causing it to spread more quickly than in water. As we observe, the color is now more evenly dispersed in the water, and the glass may appear almost fully tinted with the color. The experiment demonstrates that food coloring dissolves in water and spread throughout the liquid, creating new colors when mixed with water. It demonstrates diffusion, where molecules move from high concentration areas, the drop of food coloring, to lower concentration areas, the surrounding water, and how primary colors combine to create secondary colors.
And now, let's move to why don't water and oil mix? In this experiment, we have observed and understand why water and oil don't mix, and to explore the concept of density. As you can see in the images, the oil and water do not mix. The oil floats on the top of the water, forming a separate layer. This is because oil is less dense than water, so it stays on top. Additionally, oil molecules are non-polar, meaning they don't interact well with the water molecules, which are polar. You can notice that oil continues to stay on top of the water, no matter how long you leave it. The oil and water will remain separated. For you to have for you to understand more, we have a demonstration in the next slide.
Slowly pour oil into the container with water. You only need to pour enough to cover the top of the water. As you pour, you'll notice that the oil forms a distinct layer on the top of the water. As the result, water and oil do not mix because they have different molecular properties. Water molecules are polar, meaning they have positive and negative sides that attract each other. Oil molecules are nonpolar, meaning they do not have a charge and therefore do not interact with water molecules. Oil floats on top because it is less dense than water. The oil molecules are more spread out, making it lighter than the denser water molecules. The liquid formed distinct layers with the water at the bottom and the oil at the top, creating a clear separation.
Next is, how does sugar dissolve in water? The objective of this is to observe and understand how sugar dissolves in water and to explore the concept of solubility and solution formation. As you can see in the images, the first image observed the water is clear and colorless, and you can easily see through it. The molecules of water are tightly packed, and each molecule is made up of 2 hydrogen atoms and 1 oxygen atoms, H2O. The water has no visible sugar in it at this point. And the second image, this is the time that the sugar has dissolved into the water and the liquid looks clear again. The water now contains sugar molecules that are evenly distributed throughout the water. This is a sugar solution. The sugar is no longer visible because it has dissolved at the molecular level. For you to understand more, we have provided a demonstration in the next slide.
Slowly add sugar to the water. As the sugar hits the water, you might notice the sugar grains settle at the bottom of the jar, and you may not see any immediate change in the appearance of the water. The sugar is not dissolving right away, but you can see it sitting at the bottom. As you stir, you will notice that the sugar gradually dissolves. This experiment demonstrates how sugar dissolves in water. When sugar is added to the water, the sugar molecules are separated and dispersed throughout the water by the action of water molecules. This process forms a solution, which is a mixture where the sugar is evenly distributed and not visible as individual grains.
And the last one is, why doesn't sand dissolve in water? To observe and understand why sand doesn't dissolve in water and to explore the concepts of solubility, mixture, and particle size. As you can see in the images, look at the first image, water in the container. The water is clear and you can see through it. The water molecules are tightly packed and moving around, but the water appears uniform and transparent. And look at the second image. When the sand hits the water, the sand does not dissolve. Instead, it sinks to the bottom of the glass, forming a layer at the bottom. The water remains mostly clear, and the sand stays in separate grains at the bottom, showing that the sand doesn't mix with the water. We have provided a demonstration in the next slide.
Slowly add sand to the water so you can observe what happens. You don't need to add a lot, just enough to see the effect clearly. Even as you stare, the sand remains separate from the water. It will swirl around briefly, but eventually the sand will settle back down to the bottom of the container. You can observe that no matter how much you stir, the sand stays in distinct particles and doesn't dissolve into the water. This experiment shows that sand doesn't dissolve in water because the particles are too large to interact with the water molecules in the same way that smaller particles like sugar or salt. Sand is a solid that is insoluble in water, which is why it forms a mixture rather than a solution. The water and sand form a heterogeneous mixture where the sand is suspended in the water and can be easily separated by physical means such as filtration or decanting.
So now, let's remember mixture are always with us. Every day we need them, we use them.
Thanks for watching.